Hey programmers, Alvin here. Right now I want to go over a Python solution for this level averages problem. So hopefully you're doing these problems in order. If not, highly recommend that you do that, because this is really just a spin-off of our last problem. And so we want to return an array or a list of all of the averages across every single level of the tree. And so I think as a nice intermediate step, we'll just figure out which values belong on which level of the tree, right? Then we can just find the average of those sublists. So I think I'll start by creating that helper function. So same pattern as last time. I think I'll do this recursively. So I'll say, all right, I want to find all the levels. And what I'll do is have a function called maybe fill levels. It's going to take in the root and also the levels list that it's going to fill up, as well as the initial level, 0, right? The root definitely has level of 0. And then in my helper, I'm going to define fill levels. It's going to take in the root, the levels, and also we'll call it the level number. So this should be a good review of the last pattern that we saw. So my expectation for this fill levels function is it just gives back or rather it fills up this levels list such that it's a 2D list by the end. So I hope that fill levels kind of gives me something that looks like this, right? 3 followed by 11, 4 followed by 4, -2, and also 1. So it'd be awesome if my function can do that. And so let's jump right in. We know we're going to lay down some recursion here. So what I'll do is start with the base case. If my root is none, then just return. Otherwise, make your recursive call. So do fill levels on your root left. And what I'll do is pass along the same levels list I'm going to be adding stuff into, but also be sure to pass along the number of that new level, right? And so I know if my parent has level n, its child has level n plus 1. So level num plus 1 over here. Same thing for the right-hand side. Now I need to worry about actually adding things into the levels list, right? Sometimes I need to create a new sublist. So you've seen this pattern before. I can just check, all right, if levels, if the length of that, I guess, if the length of levels, if it's equal to my level num, then it actually means I need to create this level for the first time, right? And how do I know that? Well, if I had a tree, I actually want to see this visually again. Let's steal this. If I had some tree like this one, I know that I start out with an empty levels array. So it's empty like this. And I know that the root node has level num of 0, right? So on this very first top level call, I would check what's the length of levels. Well, right now it's 0. And that is equal to my current level num of 0, which means I should actually create that level for the first time. So I can say levels.append and add a new sublist, so a new level, containing just my roots value. And the effect that has is it inserts a new sublist whose element is just the value of 3. Right? And of course, this now changes the length of levels. Now it's 1, right? And things are kind of off by 1 here, which is okay, which is why this logic works. The length of this is 1, and the index of the subarray is 0, technically. So that's why this logic works. In the else scenario, that means that the level already exists, so just append to that existing level. So simply put, levels at level num dot append root val, right? Don't create a new sublist. Just add your value to the existing sublist. Nice, so that's looking pretty good. That should give us the correct levels. So maybe for now, just to debug, I'll print out levels before we try to solve this main problem. And I'm gonna steal this little snippet. I wanna test it manually. Don't forget, you could always just run your arbitrary code by just hitting the run button. It will not run any of the automatic test cases. I'll bring in the class definition. So I just want to see the correct levels here. We'll run that. And then from there, if that works, we can just find the average, right? Awesome. So 3, 11, 4, 4, -2, 1. So that looks good. Now it's just a matter of finding the average of each of these sublists. So if you want, you can create your own, I guess, helper function that just finds the average of a list. It's very simple. Maybe just to kind of teach you some other things that exist in the Python ecosystem. You can import from, I think it's statistics. So it's a built-in Python library. You can import the mean function. Just finds the mathematical mean, which is exactly what we want, right? Mean is the same thing as average. And yeah, it just takes in a list of things. So just to make sure you know I'm pulling no tricks here. Let's say I wanted to print out the mean of this array. Maybe I'll put some different elements. We'll put like 3, put 10, and like 11, and like 5 in there. So let's see what that does. Gives us the average of those elements. Cool, 7.25, I'll take it. I'll leave the math to you. And then from there, I can just create my final step. So after I have the levels list, for each sublist in there, you just find its mean, right? So I can say, I don't know, averages equals that, return averages at the end. And in between, I could just iterate through levels. So I can say for level in levels, so that's going to be an array of numbers, find its average. So calculate the mean of that level and take that and put it in the averages list. Something like this should be good to go. And of course, I should be returning the levels, right? Just like that, or rather returning the averages, I meant to say. Cool, let's give that a run, see what we get. Cool, and there we have our nice solution for level averages, just a spin-off of the level finding algorithm. Something I'll kind of just throw in here for funsies is, whenever you have this very classic pattern of, all right, you have some list of things, and you basically want to return a new list where you do some calculation on every original element. You can use like a list comprehension for this. So for my Pythonistas, maybe you're aware of this syntax. If not, I think it's worth learning in Python. It's one of the most Pythonic, I guess, features. So what I can do is a comprehension. So maybe in a single line, I can return a new list, right? So I'm going to duplicate this pattern basically. And what I'll do is I can bake in some iterations into this list and comprehend, basically generating elements over time. So if I just say for level in levels, I'm starting to iterate through every level. And what I want to do is find the mean of that level. So this would be an equivalent pattern, more Pythonic at that. So a little bonus around here, let's run that. Cool, and I'm quite a fan of code like that. All right, so make sure you practice this pattern. Definitely have this one down pat. Make sure you can code it on your own, because in the next problems, we're definitely going to increase that difficulty.